My name is Seth Adams. This is Lab 2, the magnetic field of a bar magnet. So, the purpose of this lab is to measure how a magnetic field is impacted by distance. We need to compare the true distances to predicted distances and understand magnetic fields using glow script. Real quick, the results of this lab that I found is that when the magnometer is approaching the magnetic field Bx increases. As it gets far away, the magnetic field approaches zero. N equals negative 2.099 and mu equals 2.93641. So for the physical concepts in this lab, you have the Biot-Savart law, the dependence distance formula, and the linearization formula, which are all right here. So for this experiment, I used my phone as the magnometer and the Tesla meter. We lined up the phone to true north and measured the distance between the magnet and the phone, and we recorded the magnetic field at that point, sort of like in this picture right here. For the initial conditions, the phone was set to true north, and the bar magnet was aligned with the magnometer. For the system for this would be the bar magnet, and the surroundings would be everything else. So, assumptions and errors that we could find in this lab. There are no magnets acting on the app from surrounding buildings or computers. That could very well happen in any scenario. We could assume that the phone is aligned with true north. It could be slightly off. And we can assume that there will be human error in the measurements or the orientation of the phone to some degree. So for our data here, we plotted a ln of the gravitational field by ln of r, and that's this graph right here with our slope being negative 2.099, which is n. And then here is all of our data graphed in Excel right here. So what do we need to find? We need to find the distance of the bar at a varying bx, find b of y by Earth, and find bx, by, bz. And then down here in the data, you can see that we corrected by due to the magnetic field of the Earth. So for our calculations, we use this equation here. Ln of the magnetic field equals ln of k plus n times ln of r. And we know that n is negative 2.099. We calculated back here that ln of k was negative 13.203. So that means k equals 1.845 times 10 to the negative 6th, and r equals 1. And we calculated mu over here using this equation, and we got 2.93641. So comparison between these. So the similarities we got is that the on-axis vectors point in the direction of mu, and the perpendicular vectors point in the opposite direction. The differences between these, the theoretical value was 3.42484 times 10 to the negative 5, whereas the measured value we got doing our experiment was 1.44 times 10 to the negative 4th. So for some what-if questions, what if we did not line up our magnometer to true north and instead put it at another angle? The results would be affected because the Earth's magnetic field would interfere with the bar magnet's magnetic field. This would skew the data a little bit to incorrect and inaccurate data. What if we stuck two identical magnets end to end and ran the experiment again? How would the measurements differ? For this, the magnetic field from the bar magnet would double, but it would still be in the same direction. All right, that's all I have for this lab. Thank you for watching.